this may actually be a piece of alien technology.
Interstellar objects, one of humanity's greatest discoveries in the 21st century, and we've detected not one, but three of them. One-eye Oumuamua in 2017, two-eye Borisov in 2019, and three-eye Atlas in 2025. These rare visitors from outside our Sun's family carry hints about other star systems, how planets form, and maybe even where life started. In this video, we'll cover everything we know about each one, their discovery, size, path, makeup, odd features, and what they mean, based on info from telescopes like Hubble, JWST, and ones on the ground up to September 22, 2025. What comes to mind when you hear interstellar object? A rock from another star? A clue to alien life? These three, one-eye Oumuamua, two-eye Borisov, and three-eye Atlas, have slipped into our system, each stranger than the last. But why should you care? Ignoring them means missing a chance to see the universe's past and our future. They're like screenshots from far-off worlds in our almost infinitely vast universe, showing how planets are built and if life spreads. 3 is a small number so far, but more could change everything. Let's unpack them by comparing how they differ across key aspects, highlighting the unique traits that set each apart. The good news is that they stick out like a sore thumb with their highly abnormal structure. They show the galaxy is full of wandering rocks, and we have recently been capable of spotting them. If we don't study them now, we lose details forever as they leave. Three-eye Atlas fading by October 2025 is our best shot yet. Its green glow and odd makeup could shift science for years. This isn't just a quick show. It's a link to stars older than ours, a peek at how the cosmos works. Miss it, and we're left guessing about our own backyard. Starting with their discoveries, each was found in distinct ways that underscore technological and observational differences. Oumuamua was detected on October 19, 2017, by the Pan-STARRS telescope in Hawaii, already outbound near the Sun, making it a retrospective catch from automated sky surveys designed for near-Earth threats. In contrast, two-eye Borisov was spotted on August 30, 2019, by amateur astronomer Gennady Borisov in Crimea using a homemade telescope, highlighting how backyard astronomy can rival pros for incoming visitors. Then, 3 Atlas stands out as the brightest, discovered July 1, 2025 by the Atlas telescope in Chile, with pre-discovery test telescope images from May 7 showing early activity, differing by being caught even earlier thanks to space-based transiting surveys, allowing more observation time than the fleeting glimpses of one-eye Oumuamua or the amateur-led find of two-eye Borisov. From these chance encounters, we can already see the patterns emerging. Now, let's measure up these messengers to understand their wild variety. When it comes to size, the differences reveal varied scales of interstellar wanderers. One-eye Oumuamua is estimated by Hubble and Spitzer at a few hundred meters long, elongated like a cigar or pancake, making it the most unusually shaped and potentially the smallest in effective volume if flat. Borisov had a small nucleus, perhaps tens to hundreds of meters, but its coma and tails made it appear larger during activity, differing by being more diffuse and fragile, as seen when it fragmented. Atlas has a modest core size from Hubble's July 21st images, teardrop-shaped and likely intermediate, but its early brightening and wide coma set it apart as visually the most expansive, contrasting one Oumuamua's compact quietness and two-eye Borisov's breakup-prone smallness. These physical forms aren't random. They're the first hints of how these objects carved their paths through space, guiding us to their journeys next. Their paths through our system differ markedly in trajectory and timing, showing diverse origins and energies. Oumuamua followed a hyperbolic curve from near Vega, already past our perihelion when spotted, speeding outbound closer to the Sun and Earth pass. Its path was the most convenient, caught post-peak. Two-eye Borisov came from Cassiopeia on a highly eccentric hyperbola, inbound when found, reaching perihelion in December 2019 before heading to telescopium, differing by allowing pre- and post-perihelion observations unlike Oumuamua's outbound-only view. Atlas boasts the highest eccentricity yet, from Sagittarius, with perihelion October 30, 2025, and Earth closest December 19th. Its path stands out for early detection far out, enabling real-time tracking with probes like Parker Solar Probe in late September through November, and ESA Mars orbiters on October 3rd. Contrasting the paths of the first two, with routes mapped, we can peer inside these travelers to uncover the stuff of distant stars that shaped them. Makeup-wise, Their shapes highlight stark chemical and structural variances from different birth environments. Oumuamua long with a reddish glow like outer solar system rocks, suggesting cosmic ray weathering on a rocky or icy body with no visible coma or tail, possibly hydrogen or nitrogen ices, differing as the least volatile, more asteroid-like. 2I Borisov was rich in carbon monoxide, 10 to 50 times higher than local comets, plus cyanide and organics from a nitrogen-oxygen disk around a metal-poor dim star, with some sun-like isotopes but overall low metals, setting it apart as the most CO-dominant. Fragile comet that died in our post-perihelion. Atlas leads with CO2 over water, plus CO and organics, the highest CO2 recorded, from a metal-poor disk older than our sun's, with fluffy grains and an age under 1 billion years, differing by its CO2-driven early sublimation and green cyanide hue, more layered and active than Oumuamua's inertness or Borisov's CO focus. Yet, it's the unexpected twists in their behaviors that truly ignite our curiosity and challenge what we know. Odd features set each apart with unique puzzles that challenge assumptions. Oumuamua's big anomaly was a slight acceleration without visible gas, possibly hidden outgassing or solar sail-like effects, plus tumbling spin, differing as the most strange in motion, sparking artificial origin debates despite natural explanations. Borisov's quirks included high CO and cyanide, breaking apart into stadium-sized pieces seen by Hubble, and a gas mix from colder origins, contrasting by being the most dynamically unstable, revealing it being more fragile unlike the other's stability. Atlas shines with nickel gas lacks iron, rare in comets, likely from CO2-rich ices. Green cyanide peaks during twilight glow. Fantail from August outbursts anti-sunward due to angle. And early fizzing, differing as the most visibly bizarre, with elemental separations hinting at internal layers. Unlike 1I Oumuamua's odd shape, or 2I Borisov's evaporative excess, these mysteries don't stand alone. They weave into a larger tapestry, revealing profound lessons about our place in the cosmos. What they mean differs in scientific implications, each contributing uniquely to our interstellar object understanding. 1I Oumuamua signifies disrupted planet formation from violent ejections, showing quiet, rocky interlopers can traverse space intact, informing exoplanet debris and interstellar survival, differing by emphasizing passive diversity over active chemistry. 2I Borisov reveals cold, metal-poor disks make volatile-rich comets with life-building organics like cyanide, unlike the other structural focuses. Atlas illustrates ancient dry systems with CO2 sublimation and rare nickel-iron splits, refining elemental processing and stellar evolution, differing as a window to older stars, with real-time data potential boosting detection strategies learned from our encounters from 1I Oumuamua and 2I Borisov. These three objects share traits from outside. Curved paths, matter from other stars, but vary a lot. Oumuamua was quiet, rocky, long-shaped, red, and oddly sped up, likely gas release. 2I Borisov was lively, small core, rich in CO and cyanide, broke apart, with sun-like measures but low metals. 3I Atlas is most like a comet, modest size, CO2 leading, nickel odd, green glowing, and glowing brighter. All have red from long space trips, but their makeup shows different births. 1I Oumuamua from a broken world, 2I Borisov from a CO-full disk, 3I Atlas from an old, dry spot. Let's talk about what this tells us. Each one shares a story about where it came from. 1I Oumuamua's quiet ways show it might be a rock piece, not icy like most comets. 2I Borisov's gas mix points to a colder birthplace. 3I Atlas's CO2 shows a dry start. Together they show star systems vary more than what we thought. Some have more heavy stuff, some less. This helps us understand how our own system formed. The odd parts add excitement. Oumuamua's speed-up could be hidden gas, but some wonder if it's something else. Atlas's nickel without iron might be from simple mixing, but it's rare enough to make us think. These things make us question what else is out there. What they mean is big. They show the galaxy sends out space rocks often. Many pass each year from models, but we see few. Cyanide and organic stuff in 2I Borisov and 3I Atlas could seed life lasting in icy covers. Odd things like 1I Oumuamua's speed up and 3I Atlas's nickel start alien talk, but normal reasons like jets or mixing hold. Vera Rubin will spot more by 2030. Comet Interceptor chases one in 2029. These objects show we're connected to a huge space family. As 3I Atlas dims this month, its mark lasts, a look into the star's tail. What do you think these objects are? Natural fossils, life carriers, or something else? Drop your thoughts in the comments, and let's discuss.